Hello, my name's Tim Pine from Footprint, as you probably know by now. Today we're here to talk about concrete in construction, which is a fairly big deal when you consider that about 70% of the people in the world live in reinforced concrete buildings, and that concrete itself produces about 8% of the world's CO2. Today, talking to me, I've got Jenny Burridge from the Concrete Centre, and I've got Will Arnold from the Institution of Structural Engineers. Will, to kick off, the two things that I'm aware of, obviously, is that there's a pile of energy that's used by a building when you're using it, that's produced by a building when you're using it, and there's a pile of energy that goes into the production of it, and a carbon that's given off. Could you maybe go into that in a bit more detail?
Sure. So we have these, as you put it, there's the making of the building, there's the running of the building, and then there's also the end of life of the building. And for a long time, we focused on the running of a building, the energy, the water use, the heating, the power, everything that goes into that. And for a long time, that's been the majority of the carbon associated with that building.
And concrete buildings are pretty good with that, aren't they?
Concrete buildings can be pretty good with that, yeah, but they add thermal mass. They're often, it gives you a simple build-up for your insulation, things like that. What we've seen over the past 20 years or so is that operational energy shrinking in response in the UK to things like Part L of the building regs, but even more, generally globally, a greater understanding of how to make an energy efficient building. That's got us to the point where, whilst it's great that this bit's shrunk, we're still left building buildings kind of in more or less the same way we were building them 20, 30, 40 years ago.
This is the thing that people always say about BREEAM, isn't it? That they doesn't really take into account enough the carbon that's produced in actually making the building.
Yeah, I think that's right. I do believe there's a point or two to be gained in the BREEAM system but not much. And it's certainly not on the same sort of weighting. And we're at the point now where the embodied carbon of the building, which is the carbon due to the construction of it and handing it over to the clients, can in some cases be as much carbon as the in-use carbon over the whole of the rest of the life of the building. And of course, add to that, we're releasing that today. And we're in the middle of a climate crisis. Call it whatever you want to do. That's today, and you can't undo it once it's done. Whereas this is in the future.
Jenny, what are we going to do about this? What's going to happen with concrete? Are we stuck in the same place, or is it getting better?
No, in this country we've done quite a lot of work for quite a long time, but certainly we've been measuring it since 1990. And so at the moment, the production of concrete is about 1.5% of the UK CO2 production.
Still about the same as air travel, though, isn't it?
So it's still high. So exactly, it's not. We can't sit on our laurels saying that's absolutely fine. We've done everything we need to do, but things have happened. So we have cut down, and we're still trying to do more to do with that. The main issue with concrete is that we use a material called Portland cement in the production of concrete. So concrete is a great material. It's sort of you can pour it into different shapes. You can make it into all sorts of different things. It's the second most used material in the world after water. It's super useful. But in order to produce concrete, almost everywhere we use Portland cement, which in the making of it, you get carbon dioxide from the heating up of the rock, which is, you need to heat it up to
1500 or something, isn't it?
Yeah, 1450, 1500 degrees C. So it's a high temperature. And in that chemical reaction that happens, you get CO2 driven off, because that's the chemical reaction that you're doing in order to make the cement. So that we can change how we make make it hot, so we can change the energy put into cement kilns, but we can't do anything without changing the chemistry for the Portland cement. So there's a chunk that we've
How can you change the energy though? Because you can't get up to those sort of temperatures using electricity, can you?
No, but they're working on hydrogen. They're also we use an awful lot of waste material.
Right. From power stations.
We've used the waste materials from everybody. in order to there's power from waste that people use. It's actually we use waste in order to for heating up cement kilns.
Maybe I could ask you a slightly controversial question. Is it in the interests of the big cement producers to actually change the way that they produce cement?
Yes.
It's a big, expensive thing for them to do.
Yes. So they have, over the years, changed things so that the cement kilns are more efficient. So they've put a lot of money into cement kilns in order to make them more efficient. Concrete's a local material, so that they have cement kilns around the country. Almost all it's about 70% of the cement used in the country is made in the country, and what comes in is actually mostly, what I haven't started to talk about yet, which is other cementitious material. So we use waste.
Yes.
As well.
Concrete or something, isn't it?
We use waste to from other industries as secondary cementitious materials or replacement cements or whatever you like to call it. But we need, at the moment, we have the requirement to have, if we use the British standards, we have a requirement to have Portland cement as part of the cementitious mix, and quite a lot. Most of the concrete made in this country has got both Portland cement and some other cementitious material. So, and at the moment it's normally ground granulated blast furnace slag, which comes from the steel industry, or fly ash, which is the power stations, so coal-fired power stations.
Well, I'm quite interested to read about it actually at the weekend, that the Pritzker Prize had just gone to two French architects, and it was really interesting. They somehow went into the philosophy of how the building could become, rather than just at the very beginning saying, right, let's get rid of it and do a really nice, beautiful building. And when you looked at all the previous prize winners, they'd all built a new building. Yeah. Do you think this is going to start to happen more?
Absolutely. It's fantastic, isn't it? I mean, this is architecture's highest prize being awarded for saving a building that already exists and turning it into something even more beautiful than you had already, which is exactly where we're going to be going. So for those of us who are lucky enough to live in the 20-30% of the world, the sort of the rich part of the world, where we're surrounded by these buildings that, you know, exist and perform perfectly well, but maybe need, you know, a new lease of life, maybe they need some recladding, maybe they need new insulation, so on and so forth, to knock those down and sort of just start again from scratch. Not only is it, you know, from a carbon point of view, it's absolutely unforgivable, but actually, you know, the general consensus of the architecture, sort of those who work in architecture at the moment, is that you're destroying quite a lot of character. I mean, we're sat in this amazing building right now where people would pay good money to have an exposed brick wall. But where better to get that from than a building that's already got an exposed brick wall inside it? So I think we are bound to see more of this. Partly there's a lot of architecture moving in this direction anyway, because, you know, it makes for interesting buildings. You're setting yourself a brief that you work with something and create something amazing out of it, rather than a blank sheet of paper.
I think you've got to be a different kind of architect. I mean, I remember when I trained as an architect, there weren't that many people who were really sympathetic enough to actually start looking at a building as a poetic opportunity rather than a piece of construction.
Yeah.
I think architectural education is probably going to have to change a bit.
I think I'd agree. I think it's a new, well, I wouldn't say it's a new breed of architecture or even engineers, but there's certainly a sort of retraining and an upskilling across the profession so that it becomes mainstream. Right. So at the moment there are architects and engineers who have only ever really worked with existing buildings and are very, very good at it. And then there's a lot of architects and engineers who have not really had that experience before. But we're living in a country where the government is imposing carbon limits. There's decarbonisation legislation where we're going to be aiming for a 78% reduction in carbon by 2035. That's going to filter down. There's going to be legal limits on how much carbon you can emit when building a building, when constructing anything. And so the quickest way to save carbon is to use what you already have. Most of the emissions on this planet are due to us making new stuff. So if we can already use what we have, And it's going to completely drive this thinking over the next decade or so, whether people...
You're both engineers, aren't you?
Yes.
You two are both going to be there at the very beginning. You know, because it used to be that the architect sort of said, column's about 7 meters in a grid, let's design it and then we'll call the engineers in. But you are going to have to be there right from day one, aren't you? In terms of really coming up with the brief as much as anything else.
I mean, if nothing else, it'll help the clients to have a say from day one, because you'll already have a list of requirements on a brief, but you're now adding into it another layer of complexity with doing it for less carbon. And so to be able to talk about material efficiency early on, to be able to talk about what the right grid layout might be for the material that you're using, because these things do kind of go hand in hand. You can't just switch one material for another and not change anything else. To have those conversations at the start as part of that brief setting, that's how you set yourself up to sort of succeed in this area. This is not about getting halfway through the design process and then saying, could we make the concrete a lower version of the same concrete? I mean, it's like throwing a deck chair off the Titanic. You're going to make a small impact. You're not going to fundamentally rewrite the brief in the first place. So it's early conversations for sure.
It's going to be really interesting. Now, I know that the developers who might watch this film are going to be saying, yes, but it takes more time or it costs more money. That's always an issue. Obviously, what's going to happen fairly soon is that people are going to start asking what the carbon footprint of the construction of their building is. So maybe they're going to have to spend the money anyway. But how much, if you start using one of your new cements, does it take longer to go off?
Yes, it does.
Right.
So the lower carbon concretes do take longer to go off.
Like how much extra a floor? Let's suppose we're putting an office building up. Can you take a stab at it?
You're probably needing another day.
Per floor?
Per floor.
Right, okay.
Or you start looking at how, or you might be starting to put a little bit more money into it, unfortunately. So, and the money goes into formwork, so that the cost of the concrete doesn't change very much. So it's not, you tend not to have to spend any more money on the concrete, but itself. But of course, the formwork is a fairly major part of the.
Why does it need different formwork?
You need more of it, so you can leave it up for longer.
Oh, I see.
Because normally you'd want to be striking the concrete, so taking the formwork away, at about 3 days, and you probably want to leave that to 4 days with the lower carbon concretes. And if it's done in the winter with a very low carbon concrete, you're talking about longer than that. These things. Because it's a chemical reaction that happens when you make concrete, the cement reacts with the water, and it goes quicker if it's hotter. Yeah. So in the summer, it's probably no different, but in the winter it'll be slower. Quite.
And more miserable. I remember working. I got a job working for John Lang as a chain boy for a year. And I remember how terrible it was at Christmas.
Yes.
Building site.
You can't do anything about that. But
No,
I mean,
the global warming's going to sort it out.
The concrete will take longer as well to go off.
Yeah, I've got to say, having poured concrete on a site in the Philippines in 38-degree heats, the opposite's not very nice either.
Yeah.
I can imagine.
So that's the way you might need more formwork, so that you can set the formwork up. Before you strike the one below. But there are ways of sort of mitigating that.
It's worth saying as well, again, this comes back to early stage conversations right at the brief stage. Where can we best employ a lower carbon version of concrete on this project? Because, okay, if you're putting 20 stories up and you really care about programme time, then 1 day per story might not be easy for you to deal with, but you could put it in the basements. Could you put it in the retaining walls?
Put it in the foundations. Where if you have got a 20-story building, it takes a bit of time to get all the load onto the foundations. So, and there's no striking of the formwork because there's no formwork in the foundations. So the slower build up of strength is quite reasonable. And we've done some work recently looking at. Normally, you specify concrete at the strength of 28 days. We've recently looked at it to see how much saving you could make if you made it into 56-day strength. and you need a low carbon concrete, so it's slow reacting, because low carbon concretes tend to be slow reacting. So if you have a slow reacting concrete, you can save about 2 or 3%. It's not a very huge amount, but it is from the low point of the low carbon concrete. You can take another 2-3% off that by specifying 56 days. You don't want to specify 56-day strength for suspended slabs, but there's no reason why you shouldn't have that in the foundations, because it doesn't need to be strong at 28 days. It needs to be
Sure, I understand. Presumably there's quite a lot of stuff in the pipeline, isn't there, Will, in terms of R&D?
Yeah.
Probably you can't talk about most of it because it'll have NDAs and you'll probably get shot. But stuff you can tell us about, what's coming along?
Yeah, so I mean, as Jenny put it, at the moment, the low carbon concrete options all involve using byproducts of industries which are not going to be at the same sort of, they're not going to be around in the same way in the future. So steel industry, coal industry. At the same time, there's all sorts of new concretes in various stages of development. Some of them have been trialled at sort of small scale. There's limestone calcined clay cements.
Yes, and the limestone fines is going to be coming in very soon. So that the standard cement won't be a Portland cement. It'll be a Portland cement with 20%
Does
limestone.
that make it so you don't have to produce so much heat from the clinker? How does that?
It's so that you can have limestone fines, which is basically limestone that's been ground fine, and that is reactive and reacts within the concrete to help produce the strong bits of concrete with the concrete matrix, and that will be the limestone cement should be coming in soon. When I say soon, in the next 2-3 years, as the standard cement. I mean, at the moment you can do it. That's getting into the British standards at the moment. It's half in there. It's going to be fully in there. We hope next year. Yeah, these things always take time, but we're looking at sort of within the next 5 years. That should be a standard. In other parts of Europe, say for Ireland, that's their standard at the moment. Yeah, and we're also looking at calcined clays, but that's a bit further down the line. But Will, you were saying that you've got something that's
more. So there are some things, like you put it there, on the horizon. They're going to hit us in the next couple of years and might be fairly mainstream this side of 2030.
Yes.
Then at the other end, I mean, we've still got researchers working at universities, and we know a couple in Imperial who are trying to make pozzolanas, which is a replacement for cement. They're trying to make it using carbon that they've captured out of the flue gases of the regular cement making process, which in theory gives you this wonderful cycle where you could plug a new factory into the side of a cement plant, and out of the back of it comes some carbon negative cement replacement. Blend the two together, you've got a carbon neutral cement mix. So I mean, really early days with that, but it gives you a sort of flavour of what people are looking at. And I think the really important thing with all of this is that we need to put money into R&D in a way that maybe hasn't been seen since the efforts around the war. We're talking about wartime R&D, right? Because if we're going to meet the ambitious carbon legislation that's being put on this country, then we need to decarbonise things like concrete, things like steel, things like timber. They all need to come down in their carbon footprint quickly. And that means trying new things we haven't done before, which means, putting investment into these. But it's not just, we're not asking investors to invest in something because it's a good thing to do. I mean, there's going to be huge amounts of money to make in this. Let's not forget that the other sort of half of the world, which is the population of Africa and Asia, is going to keep rising for the rest of this century. They need to develop. They need to keep social development going. They need hospitals, schools, infrastructure, houses, electricity networks, and concrete is going to play a part in all of that, if we're being honest. So they are going to need a low carbon version of concrete, which means that if you have backed, a product which gives you a carbon neutral concrete, then it's going to be, you're backing a product that's going to be used all over Africa and Asia in the future. So this is a really interesting time to be involved in all of these conversations.
They do, just to add on this, of what can be done now, there are, although I said that in the British standard that you have to use Portland cement as part of your mix, actually there is what they're called AACMs, which is alkali activated cementitious materials, which don't use where you don't use Portland cement. So these are being sold now. So there's companies that sell concretes made without Portland cement now and can be used. They tend to use GGBS, so the byproduct from the steel industry, and some of them use fly ash. So they still use the same stuff that you can use for the lower carbon concretes with Portland cement, but they do actually exist and are marketed now. The main concern is that trying to make sure that we've got something that we will, as structural engineers, we're happy to put reinforcement in to make sure that it's all.
And your insurance companies are happy that you did.
And the insurance company. So that's on the way to becoming accepted as with all the research that needs to go on. I mean, one of the things that we've got with research is absolutely finding the right concretes and the right cements for this. And the reason we keep talking about cement and concrete, because concrete and cement are not the same thing. I know that people tend to confuse them, but actually cement is the bit that binds it. And 70% of concrete is not cement. So,
but 70% of the emissions related to concrete is being due to the cement.
But probably more than. It's way above. It's 80-90% of it's due to the cement. So when we're talking about carbon, we always talk about cement, but actually the whole thing, the concrete is, when I talk about concrete being quite low carbon, actually it's because most of it isn't the high cement stuff, the high carbon cement. It's the aggregates.
Okay.
We probably should have said that at the start, shouldn't we?
We should have done.
It's all right. We can wrestle that around. Well, this is why you should probably be getting chairs for structural engineers at the first project meetings. This has been a fascinating talk. Jenny and Will, thank you very much for coming.
Thank you.
Thank you.